Okay, welcome back. We'll continue our discussion on object-oriented inheritance. In a previous example, we used employee. Here I have the same employee class, as you can see right here. It's the same exact employee class with the same name as a private data type. And same constructors here, and two of the constructors. These are the same constructors. Just want to capture on the camera. Same destructor as well. So nothing is different in our employee class. So I'm going to collapse this one. So you can collapse this employee class by simply clicking this plus. You can expand. And if you click on minus, you can collapse it. Especially the class which you are absolutely sure that it actually is fully verified and it was validated. So you can collapse it so you can focus on the other things. The next class I have is exactly the same, exempt. I didn't change anything. I just copied and pasted here. So I'm referring to the exempt class. Same thing with my non-exempt class. Did not make any changes whatsoever. So I just copied and pasted my program from the above, employee, exempt, non-exempt. Okay, and we know that exempt and non-exempt are the derived classes. They're based on our employee class. Then I go one step further. I say I'm going to create a contractor. Notice this contractor class has no relationship with employee, exempt or non-exempt. It's by itself. It's standing by itself, sitting by itself. So this this contractor has a contractor ID and a show method. Really simple class. I'm going to collapse that one as well. And then I have something called person. Here's my person class. Person has some kind of first name. And person also is not inheriting from anyone. And person also has a show method. Let's collapse that one too. Then I have something really interesting going on here now. I have something called part-time. This part-time, I can see it's inheriting from non-exempt, as you can see right there. Okay, so far so good. It's inheriting from non-exempt. So if we want to place this part-time is non-exempt. So this part-time is, let's see if I can show on the camera. This part-time is somewhere here. Part-time is somewhere here, inheriting from non-exempt. Okay. Then if you scroll this way, you will also notice that it is doing something else. Who can tell me what's happening here? I understand this much. What's happening here? Comma, public, person.
That's another base class you're inheriting from?
So I have something else by itself, person. I wish I had more space here. So I'm saying I'm going to inherit from this person too. What do we call this? So I'm inheriting from non-exempt and I'm inheriting from person. Multiple inheritances. So it means I have the access to the public class. I also have the access to the non-exempt class at the part-time level. So part-timer can access all the attributes of the non-exempt as well as the person. And person itself could be a very large and complex class. But this part-time class can access those members. Then there's something else happening over here. Take a look at this, the private data here. I understand the int contract. This is some kind of contract, some kind of value whole number. What's happening in this line of code?
You're creating a new contract.
Creating an
instance or object. I'm creating an object which is private to part-time of contractor type. So can I create an object in a class? Absolutely. That's exactly what we are doing here. So I'm creating a contract object or object of contract type in my part-time class. So which means this object cannot be seen from outside world. It's private. It's within this part-time class. Okay, so I have one constructor, one destructor of part-time type. Just to keep some data here, just to have some data which we can show something just to verify. I have some kind of some data, contract is 6. You can put any number there. And just to show that this destructor will be called successfully, just to verify that one. So I leave that statement there too. Okay, so I have a show method, and this show method looks really, really interesting. So when I want to call the show method, so I say new contractor. New contractor is the name of my object of contractor type. And I say call the show method of new contractor type. So the contractor type was sitting by itself. It was sitting by itself. It had no relationship in this inheritance. So if you want to see, the contractor is sitting over here. This is your contractor. This contractor has no relationship in this inheritance. I'm creating an object of this type in part-time. Part-time. So now I'm saying, because I have an object of contractor type, I can call the show method over here. Absolutely. Show method was a public method. If you create an instance of that type, which I did, new contractor, I can call the show method over there. I can also call the show method of person. Person is a parent to part-time. Person is a parent to the part-time. So I should be able to call the show method of the person. I can also call the show method of non-exempt. Why not? Because non-exempt is also a parent to part-time. I can call that show method too. And then I have some kind of statement here just to indicate that I'm actually in a show method of my part-time. So now you can see that you are calling the same show method from so many different places. So many different places. And probably in the next lecture, it becomes very interesting, because here we are very specific. We are saying, I want to call show of this type. I want to call show of this type. I want to call show of this type. What if you just let the compiler make the decision? Say show, compiler during the run time, try to figure it out. Which show I need to call? Where do I go first? That becomes really, really interesting. Okay, so this makes sense to you? You guys okay with that? So as far as multiple inheritances are concerned, all you have to do is put comma and show the second name of the class. Now you are actually inheriting from multiple, just like your parents, father and mother. You can inherit from multiple places. Then the rest will be, oh, there's another one, supervisor. Okay, so the supervisor is also not related to any class. Supervisor is also sitting by itself. So supervisor is right here. This supervisor is going to initiate everything. This supervisor is going to start calling everything. Or that's where I will be creating my instances in supervisor. So in other words, my supervisor will be running all these classes. So let's take a look here. So I have a supervisor constructor, a couple of constructors here, and one destructor, just for the camera, just to verify. So I have a supervisor constructor, which is called a default constructor, supervisor, which takes a department, name of the department here, and the value is assigned to the supervisor, and a destructor here. And then this supervisor also has a method called initialize. Does that look familiar to you?
That's what you ran.
I just copied and pasted from my main function. So the main function was copied here, and employee 1, employee 2, staff 1. Didn't make any changes. I just copied the way it was. Staff 2, non-exempt other staff. I just added one more, part-time, part 1. And this part-time is right here. If I call this part-time, I should be able to call this call person, because this part-time created an instance of this type over here. This part-time also is inheriting from person. So I should be able to access the person as well as contractor from part-time. So that's why I don't need to create a separate instance of contractor type or person type. Then I have a show, And in my show, all I'm saying, I'm going to initialize it. I'm going to initialize it, and initialize will do the trick. This initialize method is going to do the trick. Initialize has everything. And in my main function, all I'm saying is, you know what? I'm going to create one instance of supervisor type right here. And that supervisor instance or object is going to call the show method, and it will run everything. So in this way, you can actually, you might be, or your team members might be working in developing something like this. Somebody else is creating all these objects. Because these objects could be so large, so different parties are responsible for creating these objects. These classes are created by different individuals in your team. So you should be able to call them and test them. So when I run this one, so I'll get similar results. So you will see very similar results. And in a couple of places, I just left some messages there, inside person class, inside contractor class. But the results over here, we already had similar results, as if you remember. So these were the similar results we had in a previous testing. How many total objects we created? Let's count them. I can tell here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 12 objects. You say something doesn't look right, because how come I have 1, 2, 3, 4, 5, 6 employees? Did we create six employees? We did not create 6 employees. Because if you go back to your code, we created only 2 employees. How come it's telling me I'm going to shut down or close 6 employee objects?
Made exempt.
That's right. So you created an exempt. Exempt is a derived class from employee. It goes and creates its own memory of employee type. You created non-exempt. It creates an employee. You created part-time. Part-time is right underneath here. It goes and creates another employee. And something else. So we created, we created 2 exempts, sorry. We created 2 exempts. 2 exempts. So here we have 2, we got 4, we got 5, and we got 6. That's how we got 6 employees. Every time when a derived class object is created, it goes and creates an object of the base class as well. So that's why I left those statements there in my destructor, just to verify what was being created. So if we take a look again, so I'm sure I created a part-timer. I'm absolutely sure about non-exempt. And I created 2 non-exempt, because one was part-time, one was non-exempt. And even the part-time was created separately as well. And then we can verify each one of those. Okay? This concept, the whole concept, allows you to kind of realign your code in different places. Now, for example, if I go back here, let me go and find the book. I'm going to pause this for a minute, otherwise it will be too much a pause here.